Okay, I think we're ready. Let's just make sure. Looks like we're ready. All right. Although it's very laggy, I think it's good. All right. Today we're gonna do a couple of things. Really one thing. Maybe a couple can be mixed in, but really one thing. We're gonna look at this Duet board. I've got it up and running on the Tornado back here. You can kind of see the bed for it right there. Oh, and there's our little guy. But we'll look at it, or at least look what it does. I don't know if we can actually see the board itself. I'll try, but it's kind of hidden in the back. We'll look at a few other things, but mainly the Duet board today. Then later this week, Thursday, we're going to look at some topology optimization. So that's a way, CAD modeling, to create geometry based on a couple of different factors. Maybe you're trying to go for, probably it's the fact that you're trying to go for lightweight and strength. So how can you optimize a particular shape to have both of those, taking advantage of the idea that 3D printers can create, almost any shape that you could imagine, where traditional manufacturing techniques might be limited on, they can only cut from one side, or there might be some, they can't add material, only can subtract material, things like that. But that's for Thursday. Today is the Duet board. So let's see. Let's first look a little bit about this board. Here is the Duet web page, duet3d.com. So the idea here, this is another 32-bit board. We talked about it a little bit already in the back end of another video when I was still working on it, but it's actually up and running now, so we can do some things with it. So it's made, I don't know where it's made, the UK, I think. Yeah, I think so. The UK government is mentioned on here, so I assume it's made in the UK. So some big advantages. Here are their features. Fast, high quality prints. That's kind of in any of the 32-bit boards with the TMC type drivers or the quieter drivers. That's going to be true either way. Not unique to the Duet board. The network connectivity, that's probably not unique to Duet, but there are Duet boards that have built-in Wi-Fi or Ethernet. You don't have to go get another module to add on Octoprint or something like that. So it's baked into the hardware itself. So that, I don't know if that makes it unique, but it makes it really nice. But you have to be careful. Not all Duet boards have that built in to them. So there are some that don't. Easy and convenient, I guess anybody could claim that. Expandable, it is quite expandable. On this particular one, 5 hot ends and 7 stepper motors. You might wonder, why in the world would you want 7 stepper motors? What's that gonna, how is that even gonna work? The 5 hot ends, I guess you could imagine having 5 different tools. Some of them have tool changers where you can switch out for a nozzle that's one size and then print with it for a while, then another nozzle, or maybe they're set up for different materials or whatever. But why the 7 stepper motors? So what you might do, and this is something that I just recently realized I was not using quite the right words for. So I had been using, when we added the BL Touch, let's see, BL Touch, where's he at? There he is. So when I added the BL Touch, I had been talking about that as automatic bed leveling. A better, and it could be, that could be part of it, but the way we were using it was more like automatic mesh compensation or automatic bed compensation. We had been basically probing the bed before a print and driving the head up and down over the hills and valleys of the bed surface as we were printing. So we were compensating for the bed being not flat. And that's still how I'm using it here. But I think I called it automatic bed leveling. So that's a little bit different thing, and that's where these 7 stepper motors at least could come into play. So automatic bed leveling starts out the same. You go probe the bed and measure its unevenness or whatever, but you're assuming that it itself is flat, but literally not level with the print surface or with the gantry or whatever you're using to move the carriage around. And the automatic bed leveling goes in and uses stepper motors to drive the bed up and down the corners of the bed. So either there's 3 stepper motors controlling the height of the bed, you know, like an individual corner, or the 2 front corners and the back center to reposition the plane. You know, a plane can be defined by 3 points, right? And so you use these 3 steppers and assume your bed surface is flat, and you literally move the bed around until it is level with the gantry. So that's automatic bed leveling, and that's why you might want more stepper motors. I don't have any printers capable of that, and I'm not even sure that I have ever used a printer that's capable of that. But this board does have 7 stepper motors, which lets you use some of those extra stepper motors to level the bed itself. So reposition the bed in a way that it's level. I don't know if we probably won't be able to try that in this course, but I'll teach this thing again in the summer, I guess, or at least the next winter. And maybe by then I'll have something that we can do with that. I don't know. None of the printers I have right now are capable of doing that. Stepper motors, the TMC 2660, those are in a lot of these boards. Many of these boards have quiet stepper drivers. So that's not unique to the Duet board, but it is a nice thing. Flexible, what they mean here is that you can use a lot of different interfaces. So I've got an actual interface on the, see if I can get it to not glare, on the board itself. That's separate though, on the printer itself. That is separate. It doesn't come with the board. It's an add-on. But you can anything that can get to an IP address can interface with it. Again, not quite unique, because you could also do that with the Octoprint and the Raspberry Pi. Anything that could log into the internet could interface, so not unique to it. Most printers supported. That's also true for a lot of the other boards. So all of their pictures here are the Cartesian coordinate, the Delta printer. I showed you a Delta printer really quickly. We didn't run it. I just showed you the actual printer. The HBot and the, I guess they're trying to show, well, they name out an IDEX. Oh, that's supposed to be their IDEX printer. I do have an IDEX printer coming in. I don't know when though. But IDEX is, I don't know the exact, I've always thought of IDEX as independent extruder. It might actually stand for something else, but it has 2 independent extruder carriages. And so you can print 2 things at once, or you can print one thing that has 2 different materials, colors or materials. And then this other one, they have Scara. I don't know exactly how to describe that one. We'll have to look that up. But there are other styles of printers where, kind of like the 5th axis robot arms, sort of like that. I don't know if that's exactly what they mean here or not though. But anyway, it can support a lot of these different printer types. But other boards can do that also. Touchscreen support, that's assuming you have the panel I don't know if that's Duet or Du or exactly how they want you to pronounce that. But that's what the little screen I showed you was. Dual extruders, yeah, that kind of fits into the expandable up here. Cable-free control, that is nice. You can log into the internet and send everything to the printer. That way you can modify that's maybe, this cable-free control might be the biggest selling point for me. Actually, they put it in easy to configure and G-code everywhere. They put that all together. In my mind, that's all kind of the same thing that makes it really valuable that other boards don't do. So cable-free control, you could actually do the same type of thing here, print from any room in your house to a printer that had Octoprint running on it. Easy to configure. This one, I can log into a web address and change the firmware without plugging in anything. As long as the printer's running, then I can log in and modify every bit of the firmware, which I'd really like that. To me, that's the most beneficial part of this board. But these other parts, I just haven't taken advantage of all these other things, particularly the 7 extruders, 7 stepper motors. Um, I'm not using this infrared bed probe. I'm using a BL Touch. They do have some bed sensors that are specific to this. I just put the BL Touch on there since I had one. Temperature control. Now this one's a little bit weird because I've had to go in and kind of calibrate the temperature sensor myself. The built-in calibrations were not right at all for what I was using, but I'm also not using one of a thermocouple or this PT100. Those are for higher temperature printing, like much higher temperature printing. G-code everywhere again. That's what I was saying, that the configuration files are basically all written in G-code, and you can build your own little macros and put them on the home screen when you log into the web page. If you have a certain thing you do all the time, and just push a button and it runs that G-code. The Wi-Fi has WPA2. That's not unique to this. That's pretty standard for IoT type stuff. High power rating. I'm not necessarily taking advantage of this, but the stepper drivers on the board itself are capable of 2.4 amps of current per motor. So that's a lot more, like double what a typical board's going to do. The bed heater can go up to 18 amps. So you can, if I'm using a separate solid state relay for this bed, but obviously the more current you can put through the bed, the hotter it's going to get faster. So that's typically a good thing, although I'm not taking advantage of it. All right. So that's kind of an overview of the features that this is their website. So they're selling these as the features of the board. Let's see. Now, to buy the board, they actually have a store here on the purchase here, but I think it comes straight from the UK. So I think I bought mine from Matter Hackers. I believe that's where I got it. I don't actually remember. I've had it for a while, just never installed it. But there's a lot of different pictures here to choose from, and so let me tell you a little bit about what these are doing. So the one that I'm running is this one, and you have to be careful because the name of the company is Duet 3D, and then they also have models of, I don't even know if you can get a Duet one. Yeah, the Duet controller boards. Those are the version 1s, and then the Duet 3D Duet 2 is the second generation. That's what's running on this machine. And then just recently they have come out with a Duet 3. So the naming convention is just a little, you got to figure it out, just because the name itself of the company has 3 in it, and then there are boards that are 2s and 3s and 1s, and so it's a little bit confusing. Like the name of this one, Duet 3D, Duet 2 3D printer controller board. You just got to know what you're looking for. So there's a version 1, a version 2, and a version 3. Version 3 is the most recent. Most of what you're going to find is version 2 right now, which works fine. The version 3 will run a newer version of the firmware that they have. So the most recent firmware that they've released, you can't take advantage of all of the features on the previous boards. So this machine is running this one, and see, there are 2 of these also. So there's a Duet 2 3D printer controller board, and there's a Duet 2 Wi-Fi 3D printer controller board. So this is the actual one that's in this machine. So right now they're $155. So that's a little bit high for just the controller board. You can certainly get 32-bit controller boards much cheaper. And unless you're really planning on taking advantage of the extra steppers or the extra extruder motors or whatever, or something of those features, then you're not using a bunch of the board. You're just basically buying the web interface, which is nice if you're gonna. The only reason that it's a better value than maybe the just running Octoprint is the fact that you can change your firmware over the air. You don't have to plug in, you don't have to do SD cards or anything like that. So that does give it an advantage. And to do a 32-bit board and get the web interface on like the SKR, you have to buy the SKR board, and you have to buy a Raspberry Pi. So you do have similar costs. It's still going to be cheaper to go the other route, But this one has the Wi-Fi built in, and it has the 32-bit board, and then a bunch more things. So it's a little more expensive. This does not include the screen, which you don't actually need. So this screen is separate. I printed all the stuff. It literally comes as just the screen inside there. All of this other, all the gray and the black and here, that's all printed material separate that you have to print yourself. So it's literally just the screen, and then you mount it however you're going to mount it. It is nice. It is a touch screen. I keep making it where it glares a lot, but you can do all. I guess you couldn't load a print from here because it itself is connected to the internet, but only through the board. I don't think there's a way to. I mean, there's a print button, but I don't know of a way that you can load files from here to print. There might be, and I just haven't discovered it. But usually, what I'm using this for is if I want to look at the machine and adjust something on the height, you know, the homing or the bed leveling or something like that. But I don't actually use the screen itself that much, so I think it's probably not as useful. I will say that there are some procedures where, like if you're meshing the bed, or if you're doing something without a BL Touch where it needs to go in and you need to move the bed nozzle just a certain amount and you don't have the screen, then you're having to run back and forth between your whatever you are interfacing with, the computer, which may be in a different place. So it is kind of handy. It's not necessary, but it is handy if you are going to have this printer someplace where you don't have a tablet or some other thing you can get there. Now, you probably could even use your phone to do these kind of things, or certainly a tablet of some sort could do this stuff. And it also does have, you know, it's cabled to it. I don't know that they make a wireless version of the screen. And so back over here, you can see, I believe I have, I don't know if I have this one or this one. 5, I'm not sure the difference. I don't know why this one says integrated touchscreen. This is the one that I have though. So, and they actually make a 7-inch version of it also. I have the 5-inch version over here. So I would only, you know, 80, unless you're talking another $100 to add that, which to me is not adding that much feature for the price, but it depends on what you're going to do with it. So the board itself, it looks like you could get the version 2 board, which does a lot of the same things that the version 3 is going to do. The version 3 is just obviously even more powerful, but there's quite a bit of difference in price on them. So $155 plus shipping, I guess. Oh no, free fast shipping over $35. So this would certainly qualify for the free shipping. So from Matter Hackers anyway. The 3 board, we can look at it really quick, but let's see if we can find some of the features, specifications here. I know it just has even more stepper and extruder support, I believe, but it probably has other things built in. Yeah, it's got some PWM, so pulse width modulation outputs. I'm not even sure exactly what they're planning to do with 10 of those, but I think a lot of this is, hey, we don't know exactly what you're going to do with these, but we're going to give you a whole bunch of stuff and then see what happens. So I think a lot of this board is that. Plus, it does a newer version and it does run the newer firmware. I think you'd be fine with the version 2 for quite a while, though. Even it is got built-in expandability. So that's what we're looking at. We're looking at that board. So then what you do is, let's see if I can get a bigger picture of the board. There's one. So you've got the plug-ins for your stepper drivers. There are 2 Z motors over here. By default, it ships. See if I can make it even closer. It ships with these jumper installed so that one of the Z motors is kind of zeroed out. You're not using it. This is if you have 2 Z motors moving your axis up and down. most of these printers have just one by default. There are some, the A-nets and a couple of others, that have 2Z motors, 2Z lead screws, and then you can plug both of those in here. And then it's got extruder X, Y, and Z. And then these are the stepper drivers. Now these, the board itself, I'm not going to have a picture of the back side of it, I don't think, but I don't know if you could tell anyway, but the board itself has heatsink copper cladding built into it. And so all you need is a fan blowing across these, and you don't need the heat sinks on top of them. So it makes it maybe slightly thinner, but you're going to plug in a bunch of stuff on the top anyway, so you're not really gaining any size, but you don't necessarily have to worry about a heat sink falling off, I guess. So mine just has fans blowing across the back of this to cool it. It does, when you're in the control panel for it, it does give you temperatures of the board to see if you're having heat problems on the board itself. Over here, now mine is slightly different here. This is the Ethernet. It has a little antenna here. Mine actually has a separate antenna that plugs in and gives it a little more range, because my router is not necessarily close to where this printer is going to be. So I wanted more range. I'm not sure exactly how long this little antenna's range is. It has a SD card, USB, reset button. It has several headers over here for plugging in things like the panel Duet or Do board interface control panel. Has the same green terminal blocks for bed heaters and things like that. It has several fuses for various things, heaters, steppers, and I don't remember what the 3 different fuses are for, but it's the mini blade fuses. Has let's see, these are the fans down here. It has 3 controllable fans that you can either set to come on at certain temperatures, or you can set them through G-code to come on. Then it has 2 always on fans. Then it has your end stops over here. Oh, actually, these 4 are the end stops, I believe. I don't remember what these are up here, but I don't know. They're something. I don't remember what they actually do now. This board has a specific place to plug in the panel. It does have a plug-in for the probe, but the BL Touch doesn't plug into there. Their probe that goes with the board plugs in there. The BL Touch, you actually have to change out the end connectors to it. I don't think I can get to where you can see it, but I changed them, and you have to plug them into the individual pins over here. So that's not a big pain, but it does require that you have some way to actually do that. So I had little connectors, single connectors that I could use to plug in the 3 BL Touch pins on this header. I think here, and maybe there, right there. All right. So all of this is in, for our printer, is in, see if I can find where it's at. There it is. See if I can get it right side up to you. It's in that back there, that little green box. You can kind of see one of the fans. I still have a couple of wires that are that's the BL Touch wire. And then I've got, well, the antenna. I didn't plan for the antenna, so it's this little guy right there. It's just sticking on the outside right now, and so far that's fine. You do have to be able to, probably anyway, particularly going from a Creality to this, the end connectors for the wires on the Creality don't automatically just plug into these style of connectors. The stepper motors you can make work without having to undo anything. You have to cut some tabs off of the plugs, and then they'll fit in here. The end stops, notice these are all 3-pin end stops, and the Creality machines use 2 pins, and so you actually have to reformat that to make it fit and be plugged in the right side, because the 2 wires are plugged adjacent to one another, and they need to be on opposite ends and leave the middle wire open. So you do have to do a little bit of rewiring there. I just went and re-terminated all of those so that they would plug in easily. So you have to do that, and it wouldn't be too difficult on a regular printer to switch everything over. It'd take you a couple of hours to do, just making sure that you got all the things in the right spot, re-terminating any that needed to be plugged in with a different connector than what was built into the machine to begin with. And then you mount it. These boards, the 2 at least, I don't know about the 3, but the two will fit in the Creality box, and they make some adapters to fit them in there. You print out to make the bolt pattern line up right, so they will fit. It's really, really tight in there, but it will fit. This is a different brand machine altogether. This is a Tevo Tornado, and it had a separate box, and it would certainly fit in there, but I wanted to get rid of the separate box anyway, so I printed an entire case back here for it, which was probably on Thingiverse is where I got that. I didn't design it. I did have to design a mount for the power supply over here, so I built a strap and a little box down here to hold the power supply also. The Tevo originally came, or this one, it originally came with the power supply and its board and its control panel all in this separate box. There's still a couple of, wiring things that need to be worked out, just because I've got, this is not good to leave these 4 wires. They're going to get hung on things. They're the wires are going to the panel. I need to get some more shielding. Well, this isn't shielding, but wire loom or whatever to corral those a little bit. Some of what you're seeing over here, all of this you're seeing over here, though, is not part of this machine. This is getting ready for the high temperature printing on the other machine. It's going to be water cooled, I think. We'll talk about that on Thursday, or next week, I think. Let's see, what else did I have to do? I think that's all I had to do was get it rewired. This printer also doesn't come with the default extruder. I have a Chimera direct drive extruder on here, and so that one that didn't really change anything. You would have the same type of wires. You would have heater wires and maybe the BO touch wires, and you would have extruder stepper driver wires also. They just might be mounted, over here or whatever if you have the Bowden tube. So you'd have all the same stuff. This doesn't really change anything as far as wiring it goes. So you get all that done, and then you go in and let's find the board. Let's see, this one? Yeah. So then you hopefully you get it connected to the internet. So there is one step I forgot. After you get it all wired up, then you have to log in to the board itself and tell it how to connect to your internet. So that's similar to what you do with the Raspberry Pi, except on the Raspberry Pi, we just load the SD card onto the computer, edit a file, and get out of there. This one I needed to actually access the board through, how did I get, the USB, I believe, is how I got to it. I can't remember exactly how I got to that file. Now that I'm thinking about it, I don't remember exactly how I did that. But you do have to tell it how to connect to your internet. And then once you do that, and maybe it was on the SD card also, I don't remember how I did that. So this is another thing. There are a lot of guides, not guides. There are a lot of information, maybe a few guides out there on setting up a Duet board. It's not one of the more widely used boards, so the information isn't as well archived. I found one site that was pretty thorough though. If you search for Duet setup 3D printer or something like that, you'll find some pretty well organized sites. Some of them are going to be confusing because they have this version 3 firmware that only works on the version 3 boards and the version 2 firmware, and sometimes they mix things between them, and there are the version 1 setup stuff still out there on the internet, and so it's a little bit difficult to figure out which one you're supposed to be using, but you can do it. So you do get it connected to the internet. Once it's connected to the internet, then you log into the board itself. Assuming you have the Wi-Fi board, you log into the board itself. If you're not using the Wi-Fi board, then you would use Ethernet, I suppose. I don't know. I don't have that board. And you're going to have some of this stuff is going to operate off the bat, but generally what you do is you have these system files here. These are all of the configuration files that you can build, or a lot of them come by default already ready to go. There is a automatic online configuration tool where you can go in and tell what kind of printer you have. Now it's not just I have an Ender 3. I have an Ender 3. It has a 200 millimeter by 200 millimeter by 250 millimeter build volume. The steppers are running on this current. You know, there's a lot of details that you need to know to be able to use the configurator. Let's see if I can find it. Duet configure. All right, so this RRF. Oh, so it's actually not for Duet. It's for the RepRap firmware, which is what firmware. So this isn't running Marlin firmware that we've been using. This is using the RepRap firmware. And so there are a couple. You know, there's a Ender 3 Pro on here. I don't know how close to a regular Ender 3 that would be. But so maybe you could just click that. I had to go for custom configuration. And then you have to answer things like what board are you using, what firmware, and so I would be using this firmware because I don't have the 3. You can name it, what style printer is it, what are the different sizes of it, how fast do you want to home when you're homing in the X, Y, and Z direction. I don't have any expansion boards, but there are some expansion boards for the Duet. And then steps per millimeter. So there's a lot of acceleration speeds, motor current. You know, there's a lot going on what all you're trying to set up for this thing. In fact, that reminds me, I might need to go check that mine, because I don't know if this is my configuration or not, but this isn't the right motor current for that Humera. It actually runs a higher current. I'll have to check on that. What kind of end stops are you, the little triggers at the X, Y, and Z end stops? You know, are they normally open, normally closed? You're using a probe, you know, or you're using sensorless, so you can actually go in and detect stall on the stepper motor itself. It can't move anymore, and it's generating more current. The board can detect that and say, oh, it must be at the end. It's banging up against the end, so I'll consider that the end stop. So you can do sensorless. There's a lot of different things, and so you have to set all of these little options. Here's your heater options for the bed. What do you want to do with your cooling fans? What is this? This is, well, I didn't do any of that. There's your bed probing if you're going to have that. Network settings. Oh, here's where you can actually set up some of your network possibly. And then you finish, and you can download these configuration files. They'll come into a zip file, and it will populate many, maybe not all, but many of these configurations, these .g files here. It'll set up a lot of those for you. So you can get started going through that configuration tool, assuming you know enough about what the different settings are. So certainly, if you're coming from a printer, let's go to the start. That's not on one of these, the starting list, one of these, then you're going to need to know a lot of details about the printer that you are setting this up on, so that you be sure that you know that kind of thing before you get started, or you know where to find it. Then you get that running. You'll spend a lot of time in this config.g, where this is G code. The .g is G code. So you are going in here and actually setting up all these things. So you do have to be able to read some G code. There are guides that will help you. You don't have to go in and set, like some of these, all of this stuff is set through that configuration tool. Assuming you got the right numbers in the configuration tool, then a lot of this will be populated for you. You might just have to tweak something. Or maybe you don't have to. I had to go in, since I wanted to do the Z probe, I wanted to use the BO Touch, and it's not one of the ones that automatically gets configured. You have to go in and set what kind of grid you want to use, how big of a space do you want to probe, and what's the spacing between the probe points. So you have to set that in there. You had to do a couple of things with define it. You had to shut off this heater, because I'm actually using a heater pin to control the BL Touch. So you have to turn it off as a heater and turn it on as a BL Touch. There's a lot of little things like that, but you don't have to. Once you're connected to the internet to your local internet, to edit the configuration, you'll literally click on it, and I edit here, and then I hit save, and it's on the machine. So it's running the newest version of the firmware and the configurations as soon as you hit save. So that's the nice thing if you're going to be using a printer that you're experimenting with and you're trying to tweak every little detail of it, because it is a little bit of a pain to go in and update firmware through a USB or update firmware through the SD card. You know, you compile it on your computer, take it out and put it on the printer, and then hopefully it installs. This is way better if that's what you're going to be doing. So if you're going to be doing a lot of tweaks to the firmware side of things, this is so much easier to do. You can even build your own little pieces of G-code here. So on this console, all of these macros are just little G-code things that you can build your own. So if I go over here to the macros, here's one I wrote. I don't want to run it. No, I want to edit it. So I think, yeah, right click and edit. It's just 2 lines. So it's homing in X and Y. So G28 is home. And then if you put just G28, it does X, Y, and Z. Or you can put parameters, and I only want it to home X and Y. So it homes X and Y. And then G0 is the fast move speed. Actually, it doesn't really matter because I've got feed rates built into this one. So it's going to go at 4,000, or I don't remember what units those are. But that's the fast. That's kind of fast. Normally I go at 6,000, but it's not slow either. And then this is a position to go to. So that's roughly the middle of the bed. And so you can write whatever little routines you want, save them in this macro thing, and then on your dashboard you have a set of macros. So it probably won't actually do, if I click this, it probably won't do this because it's not homed. Oh, actually it will. Oh, because I told it to home before. So it's over here doing its little thing. It's homing the y-axis. And then the go to the middle of the bed, more or less. So maybe there's some reasons you want it to go to the middle of the bed, then it'll do that. Over here on the back on the panel, wait, the panel's this one. Back on the panel, it's showed me that the X and Y axis have been homed. To home Z, you just click on the button here, and it will go and home the Z axis. Although it's pretty slow. I have it because you don't want to just ram into the bed. So I have it set to home relatively slowly. Eventually it will get down there, but what it's part of the home Z, you have to tell it if you're using the probe or if you're using the switch over here. So there's a lot of little things. This is certainly not going to be as simple of a setup as switching out to the SKR board. The SKR board is probably way simpler, and a lot more people use it, I guess because it's cheaper, or for whatever reason. Probably it's cheaper. I know it's cheaper. I don't know if that's the reason people use it, but it's a lot more configuration that you need to tweak to get started with this board. All right, there it is. It finally homed the Z-axis. All right, so we can go back over here. And now it shows that Z is home. So you can do all that, which that in itself is not a big deal, because you can push home all on Octoprint or whatever and do the same thing. Like I said, the big advantage is being able to access all of these configuration files and update them without anything other than the printer being turned on and connected to your internet. You can also obviously send print jobs to it. So I built a configuration in Cura. So let's see, I can show you some of the settings there. So basically there's some start G code here that you have to add that it interfaces with the board so that it knows what temperature you're printing at and things like that. But then the rest of this, here I'm loading a special height map. So this is, it's called heat map. What I was doing there is I heated the bed, probed it in, I think it was like 120 spots or some ridiculous amount of spots that it was probed on. And then that map is stored. And so this is the manual mesh, except it wasn't manual. I'd use the BL Touch to do it. You can do it manually. So the mesh compensation, you would not want to do 120 points before every print. So you do it once and assume it stays the same print to print to print, and then you can load that map here. That's what I'm doing. I'm loading that map data. You can do this on your Ender 3 without, this is not special to the Duet board. Maybe the name of the file or whatever, but the process is not at all specific to the Duet board. And so that's what that's doing. Here's just going to the center of the, or roughly the center of the bed. That G30, that's, I saw it right there, that's probing to find the Z height. There's that map, and then the rest of it's just your regular kind of print your purge line and stuff like that. So I downloaded these from Thingiverse. These are actually way too, I don't want to print these this size. Let's make this smaller. This is just some like ratcheting clamp thing. I just wanted something that I could relatively do quickly. That looks like it won't take too long. Let's move it. I hope I didn't scale it. All right, let's scale it again. 50%. And then let's move this one. Actually, I guess I can just auto arrange. Actually, that's too close together. I don't like them that close together. Now I was printing a vase last time, so let's do 0.2 millimeter. Actually, this is a thick thing. Let's go 0.3 millimeters. I have not calibrated the printer necessarily yet. Some of it's been done, but not all of it, so I don't know if this is going to come out very well or not. We'll do 3 walls is fine. This is a mechanical device, so you know it's got a interface with these little ridges here. So I do want it to have some strength. 3 walls is kind of in that kind of strong range, but normally if I wanted an actual mechanical part, I'd do 4 walls or just totally solid. Remember the little trick with making all the top layers, all the print top layers, that makes things really strong. Right now it's at 0 because I was on vase mode. So let's go to 4 top layers, 4 bottom layers, 3 walls. Infill, that's pretty high. Let's make that at 25. I like the gyroid infill pattern. Now these printing temperatures, I remember I said that I had to calibrate it myself. So the 185 seems low, but that's actually probably equivalent to 200-ish on other printers that I've been using. So I had to do a temperature tower to get it to figure out what the temperature was best at. That is something that I've seen a couple of questions over in the Discord, or maybe they were just straight to me, I don't remember. But when you're trying to get a printer running and you know you're following the recommended settings, you print at 205 or 200 or whatever, don't assume always that your screen or whatever you're looking at on your printer says 205, that it's actually that temperature. It could be that from printer to printer the calibrations should be a little bit different. Also, the thermistor itself it's close to the nozzle, but it's not right at the nozzle, so there is a little bit of temperature difference. And it could just be a bad thermistor or whatever. So if you're having a lot of trouble with your prints just not printing correctly, although you're following the recommended temperatures, do the temperature tower and you know make it range from 20 degrees on one end or the other of what you think, and then see, it could be that this particular thermistor setup on this particular printer, 185 is the temperature I would print a certain filament at on the Tevo. Same filament on the Ender, I'm printing it at 205 and get the same results. So not everything is automatically calibrated correctly every time. So you might have to do some actual test, unless you have a separate independent thermometer that you can somehow measure the nozzle heat block temperature with, which most people aren't going to have that, at least not easy to deal with while it's printing. So that's one reason to do some of these calibrations, is because just because the printer is reporting a certain temperature doesn't mean it actually is that temperature. So I'm printing at what I would consider a lower printer temperature for this material, but it's working well. I've got it at 60. It could probably go faster, but this printer does have a really large bed, so moving the bed back and forth. I haven't switched over to solid mounts yet, I'll do that soon. But it does have the stiffer springs. I don't know if you can see them. You can kind of see down there. This it looks solid on the screen, but that's actually one of the flat wound springs. It's a die spring, so like a ejector spring on a punch and die set. It's that kind of spring. So it is pretty stiff, and it's practically solid mounted, but it does have a little bit of give to it. Anyway, you can't move these beds too fast back and forth, or they'll vibrate a lot. So I haven't tested what's the maximum speed. So we're doing 60. Retraction, we'll leave that on. I don't think that's even going to be a real issue on these prints, but there are 2 of them, so it does have to travel between them. So okay. Fan speed on this particular one. This is another thing. I was not able to and this is probably a function of the Duet board, or the Duet 2 board anyway. I was not able to maintain the nozzle temperature at 100% fan speed. So the fan overpowered the heater, and it would drop the temperature to a point that the board itself would say, hey, the temperature is too low, and I'm not going to be able to print, and it would go into a fault state. So I dropped the fan speed down to 75%, and it all seems fine. It doesn't get too hot, doesn't get too cold. It stays right at the right temperature. But I think must be I don't know if it's in the logic of what the Duet board is doing, or the Duet board itself has some issue with pumping out enough current to the nozzle heater. I don't know. But anyway, dropping it down to 75%, fix that. We'll do a skirt. We're not going to do vase mode. So let's slice this and look at it. So it says it's going to take an hour. Obviously, I'm not going to just sit here and watch it for an hour, but we'll get it started because I wanted to see how the process works. Preview just to make sure it looks right. That looks fine. All right, so we saved the file. Saved a file. We'll put it on the desktop. So it's called Tevo Tornado. Oh no, this is Tornado. Ratcheting clamp. So we'll save that. So I've just saved the file, and then get Cura out of the way. Over here, I've got the printer running. I'm connected to it. I could have been preheating it. That would have probably been a good thing to do. I don't know if I have a. I should be able to preheat button over here, I guess. You could go in here and set. You know, I'm going to do 160. Actually, I'm going to do 185, I guess. And turn the heater on, so I could turn the heater on from here. And the bed, I could set it. It was at 60, I believe. Turn that on. Well, I guess it's trying to do the bed right now, or the nozzle right now. It gives you a live readout over here. Now, these are not unique to Duet board, so this is something that other Octoprint and maybe if you're just connected through Pronterface or whatever, you can get all this through those. But right now it's heating up. But here's upload and start. So this is sort of like on the Octoprint, where you can take a file. Let's find that. It's on the desktop, isn't it? There it is. It's just a G code, so it won't preview that. Open it, and it will send that code over the internet. You get little messages down here. Blue messages are good. Green messages are good. And the orange messages mean there's some kind of fault, or maybe just an error. And so I can hear it. It's turned on some fans over here. It's basically just still heating the nozzle, which is one of the first things it needs to do anyway. It does give you, like, I'm using a 24 volt system over here. It tells me how much voltage I've got going in, which 23.9 is pretty accurate for 24 volts. It tells me where the tool is at. Assuming I've homed the machine, it knows where the tool, the hot end, is at. The MCU, that's the motherboard temperature, so it shows me that. It gives me a minimum, maximum range here, so that I want to make sure that those don't get too hot. And it will go into fault modes if anything gets too hot or too cold in the case of printing. It even gives you I asked to print at 60 millimeters per second. It'll actually live update on what it was able to achieve for any given line on the print. While we're waiting for it to do some stuff, let's look at the height map. Here's the map of the bed, so you can see all the points. that are in there. I don't know why there's such a drop. Now, this is, you know, fractions of millimeters. Let's see. The maximum deviation is negative 0.3. Oh, we got a bunch of good things happening over here. Let's go back to our height map. The maximum deviation is negative 0.3 millimeters to positive 0.14 millimeters. So it's pretty flat, but it does give you an exaggerated map of where the low spots and high spots are, although the mean error is 0.02 of a millimeter. So, and the RMS error, so root mean square error, 0.084 millimeters. So it's pretty flat. I could probably make it slightly flatter. But these Tevo Tornadoes, it does look like it has a metal bed, but this is actually a glass bed with a green coating on top of it. Is what ships with them. So it should be pretty flat. So at that point, you know, you got a trace over here showing our heaters up to oh wait, because it's at I told it to go to 160, so it'll eventually go to 185, and then it'll start printing. And this is one place where I actually do use the little panel, this guy, because I don't have a LCD screen on it. This is it. Now there might be, there are plugins on the board for plugging in your traditional LCD screen, but since I had this, I didn't do that. So I do use this one for baby stepping. So once it starts printing, there's baby step, and I can go up in or down in 0.02 millimeter increments live during the print. Again, not a feature of Duet. That's a or RepRap. That's in Marlin also. But that is one reason I use the panel. All right, so it's starting up the homing routine, and so this is kind of nice. It is basically doing Octoprint things, but I don't know. It's a nice package deal. If you know that you're going to want to do all of these things, do the over-the-air printing and configuring, do the 32-bit board with the silent stepper motors. You know, by the time you get all the pieces to do that with Octoprint and everything else, then you're close to the same price on the two boards anyway. The third edition boards are probably a little more for the Duet. Duet 3 probably is not going to gain you that much. Actually, it looks okay. Here's a little blob, but that looks okay. It's a little low over there, but we'll let it go. I never have actually checked to see. Yeah, it's adjusting up and down very slightly. I probably could do a couple more runs of the height map adjusting to get it tuned in, and all the calibrating you need to do. All right, and then from here on, it's going to be a regular print. So is it something that I would certainly not say that the first upgrade you should make is one of these boards, because you need to know a lot of background on how are you going to set these configuration files. Like if you look at this thing and this makes no sense at all to you, then it's going to be tough to know what you're doing when you need to change one of these numbers or comment out something or add a line. You can follow guides, and assuming that you have the exact same printer that someone writing the guide had when they wrote the guide, then you could probably slog your way through it. But if you're using a printer that's not one of the, like this Tevo is not one of the more popular printers, then you might have trouble if you can't read the G-code comments. We're going to do a little bit more on G-code, not this week, but I think next week. Just now, we're not going to get into this level of detail, but we'll get some of the basic stuff so that you have some familiarity with it. But if this is intimidating, then it's not a good place to start, because you do have to go in there. You have to write for the BL Touch. I had to write a couple of these, but they're like a couple of lines, 2 or 3 lines, like the deploy probe. Yeah, well, actually, I found that one. Someone else wrote that one got configured by the configuration tool, so I didn't have to write that one. But there are things like that that you might have to write. But if you're comfortable with G-code, at least to the point of, being, you might not write it from scratch, but you can kind of work your way through it. And you really want the wireless printing and you're going to mess with the firmware a lot, then this is probably a good board. If for no other reason, then you can go in and change configuration files very simply. It gives you all the other things too with remote monitoring and that sort of stuff. I have not tried hooking up any kind of cameras. I assume that is doable, but I haven't actually tried that. I don't. Now that I think about that, I don't know that it has a simple to use camera interface. So if you wanted to do time lapses, I'm not sure this will do that. I'll have to check on that. Let's see if it gives me anything. Alright, so this one, I just don't know what they're using to interface. I'd have to look into it. Because it would be nice to be able to actually see the... oh, it looks like they're using a Raspberry Pi to do it, which kind of defeats... I want to use just the Duet. So what's the integrated camera remote for time? Maybe there's a way to do it. I'll check and see. But it's a little bit expensive for if you just want the remote printing. Like, just get you a Raspberry Pi and set up Octoprint, and you'd spend way less money. If you want to just do the time-lapse thing, same thing. It's way cheaper. I'm not even sure you can do it with the Duet yet. I'll have to check on that. But so it's do you want to do all of these things? Do you want to have like ultimate control? Then it's probably something to look at. Just know that you're going to have you have to dig around in some G-code probably. You're going to have to find some forums or whatever to get some information specific to what you're trying to do. It's a interesting thing. It's not a starter thing, I don't think, but it is a powerful board and very expandable. Not future proof, but it does give you a lot of options for things you can add later on. All right, let's see. Just a little. Let's look at some prints that I have done on it, just to show that it does print. It is printing. It looks like I did start too low to the bed. That's too close. But did this guy. This is a tougher print because it's a vase mode print, but all of these ridges, like you can imagine, every layer, the number of movements that have to be made. This print is a tougher print just because of that. And so it can bog down. A regular, like an 8-bit printer might have a lot of trouble with this actually, just bogging down on all the little movements, and you might have little blobs everywhere. If anything, I'm under extruding here. I don't have blobs on any of this stuff, but I can see some thin spots. So this was this little vase mode print that it printed fine. I printed a whistle somewhere. I don't even see where it's at anymore. And it worked fine. There are some tuning, just like any printer, that you're going to need to get it running smooth that I haven't done yet. But it came out pretty well. I did finish up this guy. So this was he was not printed on here. Maybe I should print, one of these type guys on an FDM printer so you can see the difference. I printed one earlier, like in the summer earlier. But so you can kind of get a comparison on resin versus what a FDM can do. The resin is actually, even though it's printing at 0.05 millimeter layer heights, it's going to be faster than printing this same guy on the FDM printer at a thicker layer height. But it's just going to be faster. So this is him done. But the last time I showed him, he was shiny. That was the coating that I had on him. So I just sprayed him with, I think Tester's Dull Coat is what I used, a little spray flat lacquer. And then this is what you get. So I think that's probably all of the stuff for today. I've had some questions that I'll see if I can answer about what to turn in. So I went through and I thought I was up to date on all the benchies. I don't know if people have added new benchies or not. Let's see. But I was up to date on those, but maybe there's some new ones now. For the other assignments, though, they're coming up. You know, you've got 3 weeks, I think, or so to do them left. Something in that range. Maybe a little more than 3 weeks. Oh, I've done most of the benchies. There's 2 left I need to do. So the benchy is the one I do go in and I look at the, you know, there's a whole rubric for grading it. So if you've turned one in, you can, I assume you can see the rubric. I didn't make it a hidden rubric. I just don't know what you see on your side. So you know what you're looking for on that one. But all of the others, like the calibration, retraction, for temperature, for tolerance, these, what I'm looking for is that you print, like on the retraction, print one of those little retraction tests, make changes based on what it's showing you, print another one, and that's enough. You can keep printing them and tuning, but for the assignment, 2 of them is a before and after is good, and then a paragraph about what you changed and what happened. If it got worse, then that's still okay. You just say, I changed this and it came out way worse, so I went back to where it was. That's fine. Temperature, one of those with a picture, and then our paragraph reading the temperature tower. It might be that it looks perfect from top to bottom, and you can say, well, this particular filament will print equally well from this temperature to this temperature. Some materials change their, not color, but their appearance at different temperatures. So there might be a reason you want to print hotter or colder because, let's see, I don't know if I have an example. I do, but it's mounted on this printer, so you can't see it right now. But as they change temperature, they might get glossy at hotter temperatures. They might be more matte at lower temperatures. So there might be a reason there to change temperatures, everything else being the same. In general, hotter is going to bond the layers together stronger, but cooler is going to have a better surface finish in general. This is in general stuff, not rules. But you read the thing, you write a little paragraph and say, looks like I'm going to print at this temperature and based on this temperature tower, but for these reasons. Maybe all the other temperatures are like sagging and all, it's obvious, but maybe it's not. The tolerance one, this is the one with all the little wheels that you try to break free. So here, you print this one time is fine, and you just try to break open the ones that your printer can. They may not all be loose to start with. You may have to, on the back side of it, it has a little hex cavity that you can use a hex key to help break them loose. And you find out which ones are loose after you break them loose. And then you report on, it looks like my printer's set up for being able to distinguish between a 0.2 millimeter gap or whatever it is. You know, hopefully it's smaller than that. But whatever ones are free. If you want to tune this one, which is not required, but if you want to, then you're working on mainly extrusion rate, flow rate, can tune this one. And then these optional ones, they're all over the place depending on which options you choose. But in general, there's going to be at least one picture. Some of them are movable, so then 2 pictures are needed to kind of show that it's in one state and then it's in another state. Some of them are assemblies maybe, so you have to have a picture that shows all of the pieces and then a picture that it shows assembled. Or maybe it's, usually most of them are going to be 2 pictures are fine, and then a paragraph writing up what you did. Option 5 is the different one because it's a longer thing. So in this one, you're designing some little mini experiment. Maybe you want to figure out differences in infill. You know, maybe which one prints faster or which one's stronger or whatever. So you design a little experiment, do a couple of them, prints, run your experimental test, whatever that is. Doesn't have to be complicated though. And then you report your results. So it's a little multi-page with several pictures thing. I think the topology optimization is one of the things you can do in here. There's one other thing, I can't think of what it is right now. But so the option 5 is a longer one. So don't wait until the last minute thinking you're going to be able to do it in a day. Looks like somebody has submitted one of these, so I'll have to check that and see what it is. All right, I'm going to go over to Zoom, and if you have any more specific questions or other questions, I'll be over there for 40 minutes or so, and we'll answer questions over there. Thursday, we're going to hopefully do some, I think I'm going to use SolidWorks, or maybe Fusion 360, or maybe I'll try both of them. But we're going to do the topology optimization routines to see if we can kind of investigate how that works and what it does and why it's connected to 3D printing. All right, so I'll see you on Thursday.